Hello. Our goal today is to rewrite expressions with rational exponents and then also evaluate expressions with rational exponents. So the deal with rational exponents is we are used to seeing square roots and cube roots. Today we're going to express a square root as an exponent instead of as a radical. So looking down here at b to the m over n, we are not used to seeing something written as x to the 3/2, for instance. However, x to the 3/2 is going to be equivalent to a radical. So the way we're going to go back and forth between radical form and exponential form is whatever the denominator of the exponential form is, that is actually your index for your radical. So if we're looking at x to the 3/2 here, you'll notice how it's a 2 in my denominator. What that means is that the 2 is actually my index. And so it would actually be taking the square root. After you figure out what your index is, whatever the numerator is in your exponential form is whatever the exponent is inside of your radical or even outside of your radical, depending on how you want to write it. So this one here, x to the 3rd, would be inside my radical here, and the 3 was my numerator, and it is now my power inside the radical. So let's take a look at a couple of these examples going back and forth in between radical form and exponential form. So the very first one here, you'll notice it's a 9, so I'm going to use 9 still as my base. Then I see it's the square root of 9, so technically it's 9 to the 1st power. There's a 1 implied there if there's no exponent. Also, since it's just a square root, there is a 2 implied as your index. So 1 is my numerator, and 2 would be my denominator in exponential form. So what this is saying is the square root of 9 is exactly the same as 9 to the 1/2 power. Those are saying the same thing, but written in different forms. So let's take a look at the next one. Now there's more than one term. I have a base of x, and I have a base of z. Now x is being raised to the 3rd power. Z right now is being raised to the 1st power. So again, if there's nothing there, there's an assumed 1. As we're looking at this, my index is 4, which means for both of these fractions, I need to have a 4 as my denominator. So it's going to be x to the 3/4 and z to the 1/4. So looking at this 4, the index has to go to everything that is inside the radical, the radicand. Every term in the radicand has to be raised to the index in the denominator. So now let's try going backwards. Now we're in exponential form. We're going to radical form. You notice my base here is 32, so that's going to be my radicand now. It's technically 32 to the 1st power because the 1 up here is my exponent. And then this 5 down here, as a reminder, this 5 here is my index, so it's going to go on the outside of my radical here. So this is the 5th root of 32. Again, the 5th root of 32 and 32 to the 1/5 power are saying the exact same thing, but in different forms. So because of that, my next one, my d to the 7th power, would be the radicand part. The 4 would be my index. So d to the 7/4 is the same thing as the 4th root of d to the 7. The next one here, 64 to the 1/2. 64 is my base, the 64 to the 1st power, and I need to take the square root because my index here would be 2. And so I could put a 2 out in front as my index, or I also could just leave it be without the square part because that means the square root anyways. So 6 and 7 are trying to get you used to seeing things different ways. So you'll notice in both of these, my base here is going to be 81. For the number 6, you'll see the 81 with the 4 as your index, which means it's going to be 81 to the 1/4. But then on top of that, that is getting cubed. So this really could be written as 81. When we do these powers together, it's going to be 81 to the 3/4 power. So even though the exponent, the 3, is outside the parentheses, it's still saying take all of this and cube it, which is what 81 to the 3/4 is showing. You're cubing 81 and taking the 4th root. Which means when we get to the next one, you notice my exponent is 3 and my index is 4. So it's going to be 81 to the 3/4. So both number 6 and number 7 are saying the exact same thing. They're just written different ways. And with this, being able to write it in different ways is actually going to help us when we start evaluating them. So that's what's coming next. We're going to start and take and actually figure out, what does 81 to the 3/4 actually equal? That's our goal coming up. So in order to evaluate these, what we're going to do is we're going to rewrite them in the radical form, and then we're going to figure out what they actually equal, or we're going to simplify them. So 32 to the 2/5, when we're looking at this, where it's going to be the 5th root, because the 5 was the denominator, of 32 squared. So now we want to figure out what this equals, because originally 32 to the 2/5, I can't look at that and say, hey, what that equals. We want to write it in radical form because we're used to radical form. Now looking at it, I don't really want to do the 32 squared because 32 squared is going to be a large number. So I'm not going to do that. What I'm going to do is I'm actually going to take the 5th root of 32, because to me that's a little bit nicer. I'm looking at the 5th root of 32 as a reminder. For these radicals, you're going to break them all down. The 5 is saying I'm looking for a group of 5. So the 5th root of 32 is a nice number. What's inside this parentheses here is going to end up just being 2. And now that I did the 5th root of 32, all I have left to do is to square that. So the 5th root of 32 squared is 4. That would be my final answer. So let's try the next one. This one looks kind of nasty because it's a fraction to a fraction power. I don't like looking at that and saying the answer. Instead, the way I'm going to think about it is by doing the 3rd root of 8 over 27 squared. Because now when I look at this, the cubed root of 8 over 27, I can actually take the cubed root of 8 and the cubed root of 27. I can figure out what those equal, and then I can square that. So the cubed root of 8 is 2, the cubed root of 27 is 3, and now that I've done the cubed root part, now that's all that's left is squaring it. So 2 over 3 squared becomes 4 over 9. That's how we can simplify things with rational exponents. So let's go ahead and try a couple more then. Looking at these ones, now we're going to start having some negative exponents. Number 10, 81 to the negative 3/4. So this negative sign here doesn't make my answer negative or anything like that. What it does is it moves it down to the denominator. So anytime you see a negative exponent, you immediately stop and you move it to the denominator. And as you move it to the denominator, now the exponent becomes positive. Now that I've moved it down, I can write this in radical form. So 81 to the 1/4 means we are taking the 4th root of 81. This is the radical form of 81 to the negative 1/4. Now, to simplify this, what I have to do is I have to figure out what the 4th root of 81 is. And anytime you need to take a moment and break these down so you can see how they simplify, please do so. So if you take and break down 81, you'll see that the 4th root of 81 then is 3. So 81 to the negative 1/4 is equal to 1/3. So now let's try one that has a numerator here with a 3 and that negative sign. So the first thing I'm going to do is I'm going to move this down to the denominator. It's going to become 256 down in the denominator, and it's going to become a positive 3/8. Again, anytime you have a negative exponent, stop and move it down first. Now that it's written like this, now I can write this in radical form. So I'm going to have 1 over, the 8 is my index, so it's the 8th root of 256 to the 3rd power. And so now what I can do is I can take and simplify this. I'm actually going to do the 8th root of 256 first, figure out what that is, and then I'm going to cube it. So if you take 256 and you break it down, there is actually a group of 8 in there, and there's a group of 8 twos with no leftovers. So the 8th root of 256, this part specifically becomes 2. And now what I want to do is I want to take and do 2 to the 3rd power. This becomes 1 over 8, and that would be my final answer here. So now what happens if you have two things with variables and no numbers? First, what we're going to do is we're going to take these, we're going to move them down to the denominator. You see this negative exponent means we're immediately moving it down and it's becoming positive 1/4, but in the denominator. So it's 1 over x to the positive 1/4. Now I can rewrite this in radical form. It's going to be 1 over the 4th root of x. Now you might say, hey, this is simplified. There's nothing I can do with this. But the problem is we cannot have radicals in the denominator. So we are actually going to have to take care of that. And if you go back to your simplifying radical rules, you can go back in your notes to see what to do here. We want to get the radical out of the denominator. We are looking for groups of 4. I have 1x, which means I'm missing 3 in order to make a group of 4 in the denominator. By multiplying by x to the 3rd, now I have the 4th root of x to the 4th when I combine those two in the denominator. And so by simplifying that then, that's supposed to be a 3 up there. By simplifying my denominator, I can take that out and I would just have 1x in the denominator with no more radicals. So my simplified answer is the 4th root of x cubed over x. Number 13 is going to be very similar. I see the negative exponent, so I immediately move everything to the denominator and I change the exponent from a negative to a positive. I now can write this in radical form. It's the 4th root of y cubed in the denominator. And much like the last one, I cannot have a radical in the denominator, so I am going to have to multiply by something to get a group of 4 in the denominator. Right now I have 3 y's. I am only missing 1 y in order to make my denominator into a group of 4. And so by multiplying by y to the 1st power, my numerator becomes the 4th root of y, and my denominator becomes just one group of y's that I took out. So now we can simplify things with numbers, we can simplify things with variables. We also have one other thing that we are going to do. We're going to work on simplifying things that look like they're simplified to their fullest, but they actually can reduce a little bit. So if I were to say the 4th root of 49, you would look at this and say, well, 49 is 7 times 7. I can't simplify this anymore. And that's true, except when we write 49 a different way. Since 49 is 7 times 7, I can write it as 7 squared. This 4th root, as a reminder, the 4th root can be written as an exponent. It would be to the 1/4 power. So if I combine these, this becomes 7 to the 2/4 power. And here's where we can simplify this, because 2/4 becomes 1/2 when you reduce that fraction. And so 7 to the 1/2 power is actually the same thing as the square root of 7. So this does not look like it could have simplified at the very beginning, but we do end up with the square root of 7 overall. The next two are very similar, so if you see something that you don't think can simplify, ask yourself, can I write it a different way? 144 is 12 squared, and so if you combine that with 1/4 power, you actually can reduce this to the 1/2 power and get the square root of 12 as your simplified answer. The next one is very similar. 4 is 2 squared. You have the 1/6 power, so you get 2 to the 2/6, which reduces to the 1/3, which makes the cubed root of 2. Thank you very much. I hope this helped and have a great day.